So today's target will be understanding distance measures in machine learning. We know that distance measures such as Euclidean distance or Manhattan distance or Minkowski's distance, cosine similarity, Jacquard similarity, Hamming distance, Mahalanobis distance play a huge role in machine learning algorithm implementation, especially in clustering, classification, information retrieval. So what distance measures do is they'll be quantifying the similarity or dissimilarity between data points. They'll be choosing an appropriate distance measure that can significantly impact the performance of a machine learning model. So what we'll do is we'll be understanding distance measure concept with the help of Euclidean distance per se and with the help of K-means algorithm. So K-means we know is a popular clustering algorithm, right? And it is also called as K-means clustering. So let us look at K-means clustering. So I'll be skipping this and I'll be directly jumping to K-means clustering because initially you have this different types of machine learning, and we know that this clustering comes under unsupervised learning. And we know clustering is grouping, and the data is unlabeled data, and depending on the similarities we will be clustering. So the other areas are association mining or dimensionality reduction. So basically, whether it is clustering or association or dimensionality reduction, they all come under unsupervised machine learning. And unsupervised machine learning has unknown data, a lot of exploration. So that's what is the purpose of this. Now, what is cluster analysis or clustering? We are grouping set of objects such that suppose some objects are in the same group, that means they are similar to each other. Objects in other group, they are different. So it comes under exploratory data mining, this clustering, and it is used for data analysis, and many applications are there, whether it is image analysis, information retrieval, autonomous vehicles, etc. Now, I need to understand K-means algorithm. Why? Because I want to understand clustering. And why clustering? Because I know that in clustering, distance measure is used. That too, Euclidean distance measure is used. So I'll be understanding Euclidean distance measure through clustering and K-means clustering concept, so that I can relate with all the distance measures which I had just mentioned. So let us go for K-means clustering algorithm, and let us say this is my data set, and you can see the data set here. This data set has what? Heights and weights of persons. Suppose a person has a height of 185, his weight is 172. Suppose his height is 188, his weight is 177, like that. So this is a sample data set. This sample data set consists of persons, heights and weights, and this is the plot of that sample data set. Say for example I have this 170 and I have somewhere here 56. So this data point 170 and 56, right? So now how K-means clustering works is we'll be deciding the value of K as 2. So the value of K as 2 means the number of clusters. So we are saying the number of clusters should be 2. So and the value of K is 2. So we have 2 clusters and we'll call them as K1 and K2. Okay. Now I need to initialize the centroids of those clusters. Centroids means, let us say, central points. So cluster 1 is K1, cluster 2 is K2. So I'll be picking up 185 and 72 combination for cluster 1 K1, and I'll be picking up say 170 and 156 for cluster K2. So you can see here 185 and 72 for K1 and 170 and 56 for K2. Now we know there are many distance measures, but our focus is on Euclidean distance. And this is the formula for Euclidean distance. What is the formula for Euclidean distance? Xi minus yi whole square root of that, summation of 1 to k. So what I am doing is, now I know K1 is 185 and 72, K2 is 170 and 56. So I'll be finding out using Euclidean distance, the distance from cluster 1. So you can see here K1 with itself 185 minus 185 whole square plus 72 minus 70 whole square is 0. Okay, but K1 from K2, what is K2? K2 is 170 and 56. So 185 minus 170 whole square plus 72 minus 56 whole square, that's coming to be 21.93. So similarly, K1 K2 170 minus 185 whole square plus 56 minus 72 point, so it is coming to be 21 and 0.93 and 0. So I'll be assigning this first point as in cluster 1, this second data point in cluster 2. Let us go for the third data point. What is the third data point? 168 and 60. 168 and 60. So for this third data point, I'll be finding out, the third data point is 168 and 60. Again, I am finding out the Euclidean distance, which is 168 minus 185 whole square plus 60 minus 72 whole square. That's coming to be around 20.808. Similarly, the same data point for K2, 168 minus 170 whole square plus 60 minus 56, so it's coming to be 4.472. So if you see here, which is having the lower value, this is having the lower value, 4.472. So this data point 168.60 is assigned to which cluster? It is assigned to cluster 2. It is assigned to cluster 2. So like that, we'll be checking for rest of the data points also. But before that, we now know that the distance, minimum distance is from cluster 2. So what we'll be doing is, I'll be updating the cluster centroid. I'll be updating the cluster centroid of K2. How I'll be updating the cluster centroid of K2? By taking the average. So 170 plus 168 by 2, 56 plus 60 by 2. So K1 is already fixed. K1 centroid values are fixed, 185 and 72. But the revised centroid values of K2 are 169 and 58. 169 and 58. Now, for the remaining data points also, we using Euclidean distance, will be finding the minimum Euclidean distance and updating the center clustered. For example, the next data point is 179 and 68. Let us see in our data set also. 179 and this is our data set, 179 and 68. So for this data set, again what we are doing, we are using Euclidean distance. Where is that? 179 and 68. For this data set also, I will be finding out the Euclidean distance. But now with cluster K2, the revised centroid values are 169 and 58. So now you can see here the lower distances of cluster K1. The lower distances of cluster K1. So it means what? Now the centroid has to be revised. How I am going to revise the centroid? By taking the average of this with 179 and 68, which is coming to be 182 and 70.6667. So like that, and you can see here the assignment of this data point 179 and 68 is to cluster 1. So like that, for all the rest of the data points, I will be checking this data point is for which cluster. Say for example, 179 and 68 is assigned to cluster 1. Okay, 168 and 60 is assigned to cluster 2, like that. And you can see here, when I plot the data points, I am getting cluster 2 here and I am getting cluster 1 here, right? So the same thing you can see here, I practiced on an Excel sheet. This is the height and this is the weight. Cluster K1 I have taken as 185, 72. Cluster K2 I have taken 170, 56. So after that, the third data point, I am taking 168 and 60. And with that, the same thing, whether it is nearer to K1 or whether it is nearer to K2, I am calculating. Okay, so you can see in this example what we are doing is we are using Euclidean distance. We are using Euclidean distance for finding the similarity. Which one is nearer point from the cluster. So now you know the importance of Euclidean distance in this example. What is the importance of Euclidean distance here? The importance of Euclidean distance here is I need to find out this data point is belonging to which group or belonging to which cluster. So it means distance measure, Euclidean distance is used for what? Similarity. It is used for what? Grouping. It is used for what? Clustering. It is used for what? K-means clustering. So like that, there are other distance measures also which you have been saying, like Manhattan or Minkowski, or as I mentioned here, Manhattan is there. It will be used in robotics, L1 regularization, lasso regression, clustering. Minkowski distance is there. It will is used in again K-means and distance-based classification. Cosine similarity is there. It is used in text mining. It is used in recommendation system. Jacquard similarity is there. It is used in image segmentation, recommendation system. Hamming distance is there. It is used in cryptography. Mahalanobis distance is there. It is used in credit scores or anomaly detection. So like that, we, the help of this example, K-means clustering, we try to understand distance measures. And if you look at this table also, no, so you can see here, if Euclidean distance is there, it is suitable for continuous data. And applications can be clustering or KNN. K means clustering or K nearest neighbor. Manhattan is there, it is for grid based distance. It is used for city planning. Cosine similarities, it is suitable for text and vectors. It is used in NLP. Jacquard is there, it is for set based data. It is used for recommender systems. Hamming is there, it is used for categorical or suitable for categorical or binary data. It is used for error detection. Mahalanobis is there, it is used for fraud detection. Is it not? So from this discussion, we know the importance of distance measure in machine learning, right? So it is very important that I should select the appropriate distance measure so that my model becomes more accurate and more efficient. So I know that the distance measures are used in various machine learning applications like clustering, classification, recommendation systems. Is it not? Now, coming to implementation of K-means clustering, I have one PDF wherein I had implemented that in different ways. You can see here, this K-means clustering I have used in right here. You can see here in R programming. I have taken my data and I have applied the K-means and the centers are 2, and this is how the cluster allocation has happened here. So very simple example of K-means implementation using R programming. This is the code for R. This is the code for R, and the data, the file which I had taken, that is k.data1, this heights and weights, and this is the same file. The same file is that. Is it not? Now the same K-means can be applied in Veka also. Veka is a well-known open source tool, right? So what I can see here is I have the data set I have taken here is iris data set, and which has 150 instances, and this is the visual representation of the data set. Now I am going for cluster evaluation here, and I am applying the simple K-means algorithm, and this is my data points, and we have taken the test set here. Ultimately what I am seeing here is there are in one cluster there are 2 instances, in another cluster there are 10 instances. So that is what you can see here, the example code in R programming as well as Veka tool. You can also go for a simple Python code also. See here, these are my data points which I have taken. Is it not? And I have decided the centers, and I imported Kmeans here. The cluster size I have mentioned here as 2, and I can see here the output of that. I also have here, I think here Python code example is here also. Let us check. So you can see here in the Jupyter notebook, Python code is being mentioned here. Pandas, NumPy is coming, then Seabone. Then I am reading a file, and the file name is kmean.csv. That file can be that Excel file which I mentioned. And these are the data points in that file. And here I am importing Kmeans from sklearn.cluster. And I am implementing Kmeans where the cluster size I am mentioning as 2. And I'll be getting the results. So this is a simple example wherein the final outcome will be coming to be like this. There are 2 clusters and these are the data points in these clusters, kind of. Okay, so what we did was, our objective was to understand distance measure, and there are many distance measures, but that we understood through Euclidean distance application in K-means clustering, right? Thank you.